Hi everyone, this video is on solving single variable inequalities and graphing their solutions, in other words representing their solutions with a picture on a number line. It's important to note that this is single variable equations. It's not two variables such as x plus y is greater than 10. This is about one single variable. So the first thing we want to get underway is the idea of the notation. Hopefully everyone's familiar with this symbol. It's called the inequality symbol. If you read it from left to right, this is read as x is less than negative 3. And over here, x is greater than 2. You really want to avoid saying the alligator wants to eat the x, or whatever metaphor you have from the old days. It's fine if you want to use that, but you really have to get used to reading it left to right. X is less than negative 3 or x is greater than 2. Now, some people, it is true, it's absolutely true that this could be written like this, okay? It could be written that negative 3 is greater than x, and that's absolutely true, but for most people that is a black hole of confusion, so you're probably best off just referring to that, like in a sentence. You put the variable first, so it's going to be x that's greater than negative 3. So for notation purposes, if we could avoid saying 2 is less than x, it just makes life easier. Okay, so how do you represent these? These are not one solution problems. X can be any number over here, any number that's less than negative 3. So you go to negative 3 and you realize here is 0, less is to the left, greater is to the right. So if where x is at less than negative 3, you're going to go to negative 3, which is right here. It's less than negative 3. It does not include negative 3, so you don't darken that in because that would imply that you're including negative 3. Less than is this way, and you draw a line. The line is made up of an infinite number of points. Each one of those points represents one of the possible values of x, which are infinite. So long, and they exist all over here, so long as you are less than negative 3, any point there will be a solution. If it were to include it, if this were x is less than or equal to negative 3, the inclusion means you would darken in at negative 3, saying yes, negative 3 is included. X is greater than 2, of course it would be over here. There's 2, it's greater than, it does not include 2, it includes 2.01. 2.001 does not include 2.0. 2 is the barrier. It's right at the edge. Everything this way is greater. All these points up here included in this line are solutions to the inequality. All the examples that you've been given in the past apply to equations that they do just like in inequalities. For example, if these folks over here weigh more than these folks over here, if you took one of these off, you would still have a true equation where the left side would still be less than the right side. Similarly, if we had decided for whatever reason to make everything on this triple as big, and we multiplied this side by 3, we would have to multiply this whole side by 3, and we would have something that was 3 times as weighty on this side, 3 times as weighty on this side, but the inequality would not be changed. The right side in this case would still be greater than the left side. So the solving of these inequalities is exactly the same as equations. Go ahead and pause and solve this simple inequality and graph your solutions. Okay, so hopefully you saw that this is adding 5 and you subtracted 5 from both sides of the inequality. 2 minus 5 is negative 3. The inequality sign comes down. X is greater than negative 3. Here's negative 3. X is everything that is greater than negative 3. These are all your answers. There's an infinite number of answers. Here's another simple example. Go ahead and use your property of inequalities to simplify this and graph your solutions. So hopefully on this one you saw that this is subtraction of 15, and you decided you will add 15, undo that. 15 and negative 13 is negative 2. Negative 2 is less than or equal to x. Okay, this is written in that form that can be confusing for graphing, so it's probably better to transfer it into this form. It's true that negative 2 is less than or equal to x, but it's also true that x is greater than or equal to negative 2. That's generally the easier form. You go over here to negative 2. It includes negative 2. You darken negative 2 in, and x is greater than, so you draw the arrow to the right, because greater is to the right. Okay, the pattern continues to be exactly the same with multiplication and division. Please go ahead and show what you would do to both sides of these equations and graph your two sets of solutions. Okay, so in the left, it's x is times 5. You can divide by 5. X is greater than negative 5. You do not include the negative 5 when you're showing solutions, and x is anything that's greater than negative 5, so the arrow to the right. On the right, it's 1/3 x. I chose, rather than to divide by 1/3, I multiplied by a reciprocal 3. 3 times 2 is 6. 1/3 times 3 is just 3, so x is less than 6. It's not including 6, so you don't fill it in, and x is less than 6, so it's everything to the left. You can check all of these answers by plugging in 0, which is a very convenient number. Is it true that 0 is less than 6? Yes, that's true, so your solution checks. Is it true that negative 5, or try 0 again, is 0 greater than negative 5? Yes, it is. That checks as well. If you want to check the border, that's a good idea. It's a little bit hard. You would want to plug in negative 5 here, and you should have it equals negative 5, even though technically that's not a solution, but that is the border. Similarly, if you were to check this solution and you plug 6 in the original, 1/3 of 6 is 2. 2 equals 2, so that does check, even though 2 technically, even though 6 is not actually a solution. It's just the equal point, it's the border. So here's our first set of special cases. Please pause and give your two solutions. See what you get in your answer and see if you can interpret your solution like you did in 2 homework assignments ago. Okay, if you did distributive property carefully, you notice both of these equations came out to 6x was 4, 6x was 4. In fact, they were totally identical with the exception of the sign, the inequality in the middle. In the end, on the top one, you got negative 3 is less than 4. Well, when is that true? Well, that's always true. That means this is an identity. Any number is going to work in here. On the second one, you got negative 3 is greater than 4. Well, when is that going to be true? That is never going to be true. Therefore, the bottom inequality has absolutely no solutions whatsoever. This is the one tricky thing you have to watch out for when solving inequalities. In this case, x is being multiplied. It's being multiplied by negative 3, and you want to divide. So you're going to have to divide by negative 3. And the rule, you can write this down, the rule is that when you are dividing both sides of an inequality by a negative number, you must change the direction of the arrow. You must change the sense of the inequality. Because when you divide by a negative, the negative things become positive, and the positive things become negative. The big becomes small, and the small become big. Therefore, the direction of the arrow, the sense of the inequality, must change. You can always verify that this is correct by checking your solutions. Your solutions are that x is greater than negative 3. Here's negative 3. Everything over here is a solution. Plug in 0. Is it true that negative 3 times 0 is going to be less than 9? Yeah, that's true, because 0 is less than 9. Check the border. X equals negative 3. Negative 3 times negative 3 is positive 9. They are equal, even though negative 3 is not actually a solution, it's the border, but it does in fact check. So you're checking the border, and you're checking to make sure your arrow is going the right way, and you're showing the solutions that are on the, you're showing the correct solutions, rather than if you went the other way, you'd be showing all the things that weren't solutions. Okay, so here are your 5 homework questions for tonight. Please show all your work, show all your solutions, graph all your solutions on a number line. You should have a number line clearly labeled, and darken in if it includes it, show the arrow in the right direction, and most importantly, you should check your solutions. Number 1, check the border. Make sure it's the equivalent point. Number 2, check an easy number in your solution set. Just choose an easy one, any number that's in the area that you've shaded, and it should also make a true statement. Good luck.